Good morning and once again welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And we continue to explain shape and space 7. And today we'll be looking at volume of similar shapes. We have talked about area of similar shapes, and we have talked about similar shapes are shapes that look the same, but of course, they could be of different sizes, and that is it. So I would want to consider a cuboid that is of, let's even say, 1 centimeter by 1 centimeter by 1 centimeter, and you can see that the volume is 1 centimeter cubed. If we double the dimensions correspondingly, you will have now this cuboid being enlarged. That is the word, is being enlarged proportionally. This is 2 centimeter, 2 centimeter, and 2 centimeter. And the volume here is 2 times 2 times 2, which is 8 centimeter square, or rather cubed. I want us to talk about the volume scale factor. The volume scale factor is the volume of new over the volume of old or original. Meaning that if you talk about the volume scale factor in this particular example, you will take the volume of new to be 8 all over 1, which is 8. That is the volume scale factor. If we would wish to now relate this with the linear scale factor, you will also see that the linear scale factor is the length of the new, which is the length of new over the length of old. And I said corresponding length, not any length. You cannot compare length and here you compare with height. It doesn't work that way. If you're looking at length, you must also look at length across. That's why I am very careful in indicating corresponding length, meaning that the length of the new is 2, the length of the old is 1, which is 2. Now, it must be seen that the linear scale factor is 2 and the volume scale factor is 8. Very well, it's very clear that the linear scale factor cubed is going to give us the volume scale factor. Just like you can see 2 cubed is going to give us 8. So this one is a very important piece of information. So what are we saying? We are saying this, that the volume of new over the volume of old is very much equivalent to the linear scale factor cubed, and both of them give us the volume scale factor. This never forget. Forget everything but not this. Again, just like we said, the area of new over the area of old is the linear scale factor squared, which is the area scale factor. Volume of new over volume of old is the linear scale factor cubed, which should give us the volume scale factor. And I would want us to just go straight to an example. And let's talk about example 10. Example not 10 but 19. Let's talk about example 19, and on page 159. The two cylinders, and I want to put them here. That is cylinder 1. That is cylinder 1. And there is cylinder 2 here. a relatively smaller one. And we are talking about this one is having a height of 6 centimeters, and that one is having a volume of 54 centimeter cubed, and this one is having a height of 4 centimeter. So we are supposed to look for the volume of the smaller one. Find the volume. The two cylinders shown are similar. They have to be similar. The volume of cylinder C, this is cylinder C, and this is cylinder D, is 54 centimeter cubed. Find the volume of cylinder D. It goes without saying that we have the volume of the first one, but we don't have the volume of the second one. That means we do not have complete information when it comes to the volume, but we have the height of the old and the height of the new. So we have complete information as far as the height is concerned. So the linear scale factor here is the length of the new, which is 4, over the corresponding height of the old 6, which is basically 2 over 3. Yet we know if we want to get the volume of the second one, then we must be attracted to the volume scale factor, which is the linear scale factor 2 over 3, this time cubed. And it goes without saying, this is going to be 8 out of 27. What does that mean? If we go back to this statement, the volume of new over the volume of old should give us the linear scale factor cubed, which is the volume scale factor. Incidentally, the volume scale factor is the linear scale factor cubed, which is 8 out of 27. Meaning that the volume of new over the volume of old is very much equals to the volume scale factor, which is 8 out of 27. And what is the volume of the new? Let's call it D. The volume of the new is going to be D. D over the volume of the old, which is 54, giving us 8 out of 27. And because these are equal fractions, we are always allowed to cross multiply, giving us 27D is equals to 54 times 8. If you now want to make the D the subject of the formula, you divide both sides by 27, divide both sides by 27, and clearly your D is, this is 2, your volume of the part D is 2 times 8, which is 16 centimeter cubed. And that is as simple as that. It is as simple as that. Please remember we have used the linear scale factor because that is where we had full information. Linear scale factor has brought us to the volume scale factor by cubing it, giving us the volume scale factor. We know the volume of new over the volume of old is equivalent to the volume scale factor, and we have simply related them that way until we make the volume of D, the volume of D, which is the volume of the new, like 16 centimeter cubed. Yes, we should be on the lookout for example 20 in the next video, and let us exactly see what is it that we can do to achieve what we want. All right.